Algebra 2, 4.6a, Inconsistent and Consistent Systems. Now, if you haven't seen the previous videos for Chapter 4, you may get confused, okay? So I just want to let you know there's links in this video's description so you can watch those. Some systems of equations have no solution, and if a system doesn't have a solution, we say it's inconsistent. If it has at least one solution, we say it's consistent, and if it has infinitely many solutions, we say it's dependent. We can determine whether a system is inconsistent, consistent, or dependent by trying to solve the system. And for a system to have one solution, its graphed lines need to intersect at a point at x and y. So here's our first system of equations. We've got two equations here, this blue one and this green one, and we need to eliminate a variable. So in order to eliminate a variable like x, we need to multiply it by a constant so that we have additive inverses, a negative and a positive. So we can multiply this green one by a 2 to make a positive 2x, and this negative 2x will create a zero pair because there'll be additive inverses. So we multiply the green one by a 2, and every single term, even after the equal sign, and we get a positive 2x minus 6y equals 2. When we slide the blue one over, it's a negative 2x plus 6y equals 5. Well, look what happens. Not only did we create a zero pair here, but we created a zero pair here. That means 0 plus 0, which is 0, equals 7. Well, that doesn't make any sense. That's inconsistent. There's no solution to these. We can graph these equations by putting them into slope-intercept form to see where the lines are. Remember, y equals mx plus b, and the m is the slope, and the b is the y-intercept, where it hits the y-axis. So we take this first one, x minus 3y equals 1, and we add a negative x to each side, and we get negative 3y equals negative x plus 1. Now we can divide each term by this negative 3, and we get it into slope-intercept form. So we know the slope is a rise of 1 and a run of 3, and it hits the y-axis at negative 1/3. We do it for the blue one, this negative 2x plus 6y equals 5, and to put it in slope-intercept form, we add 2x to each side. We get 6y equals 2x plus 5. We divide each term by that 6 coefficient, and in slope-intercept form, we get y equals 1/3 x plus 5/6. So we know the slope is a rise of 1 and a run of 3, and it hits the y-axis at 5/6. Now, if you've been watching my videos all along, look, it's got the same slope, but hits the y-axis at a different place. There's no point of intersection. The lines are parallel. If they've got the exact same slope, then they're parallel. This system is inconsistent. All right? So when they're inconsistent, they make parallel lines. Let's take a look at this one. Now we've got 3 equations in this system, and what we can do is, because this already has a positive x and a negative x, we could just stack them and eliminate that x because it created a zero pair. They're additive inverses. Now, a positive 2y minus y gives us just a y, and plus 3z equals 1. Now we can take this blue equation and multiply it by a negative 1, and that'll give us additive inverses here. We'll have a negative y and a positive y. So we multiply all the terms, including the equals 1, by that negative 1, and we get negative y equals 3z minus 1. We slide this red one over. We create a zero pair here, but uh-oh, it created a zero pair here also. Now we've got 0 equals 3. Again, we have an inconsistent solution. So when it's graphed, these lines are going to be parallel also, aren't they? Now take a look at this one. Now we've got 2x plus 3y equals 4 and 3x minus y equals a negative 5. We need to find additive inverses. Well, right here would be very easy to eliminate this y because it's got no coefficient. We could just multiply this blue one by a 3 and create a negative 3y to this one's positive 3y. So that's what we're going to do. We multiply the entire equation, including this minus 5 answer, by that 3, and we get 9x minus 3y equals a negative 15. Now we've created a zero pair in the center and eliminated the y, and we get 11x equals a negative 11. We can divide each side by that 11 coefficient, and we get that x is equal to a negative 1. Now we plug in that x equals -1 into this blue equation. So now we've got 3 times -1 minus y equals -5. And that just means we have -3 minus y equals -5, don't we? 3 times -1 is -3. Now we can add 3 to each side of the equation, and we get -y equals -2. Now there's really an invisible 1 coefficient here, isn't there? So we can divide each side by -1, and that gives us y equals, 2 negatives make a positive, y equals 2. So our answer is a -1 and a 2. Now if we graph them in slope-intercept form, this y equals mx plus b, we can take that first equation, put it into slope-intercept form by subtracting the 2x from each side and dividing it by the coefficient. We're going to get that y equals 2/3 x plus 4/3. And then when we do it to the blue one, 3x minus y equals -5, we could subtract 3x from each side, and we get -y equals -3x minus 5. There's really an invisible 1 coefficient here, isn't there? So we can divide each term by that -1, and we get y equals 3x plus 5. So now here's our 2 equations in slope-intercept form. When we graph them, we see they intersect. The green one's got a negative slope of 2 is the rise that's going down, and the run is 3. Remember, when it's a negative, the line falls to the right, and when it's positive, when the slope is positive, it rises to the right. So we know this line is going to fall to the right, and it's going to hit the y-axis at 4/3, which would be like 1 1/3. So the green one is going to hit it right here at 4/3, and it's going to have a slope of a -2/3. See? So if it went down 2 and over 3, we'd have our other point, see? And then to graph this blue one, it's got a slope of 3, so there would be a rise of 3 over a run of 1, wouldn't it? And it hits the y-intercept b as 5, so it hits the y-axis at 5 right here. And if we do a rise of 3 over a run of 1, here's our other point, we draw the line, and look where they intersect. They intersect at -1 for x and 2 for y. And you know what? That was our solution. -1 for x and 2 for y. So they intersect at -1 and 2, so this is consistent. There's a solution. They intersect at that point. See? So now we've got our next video is 4.6b, and we're going to talk about dependent systems of equations. I'm going to put this video into the Algebra II playlist, and there's going to be a link to Algebra I system of equations, linear equations for Chapter 8 in here. And I'm also going to put a link to the Chapter 8 playlist from Grade 8 Math, because that talks about substitution and elimination. All right? So I'm going to have 3 playlists that talk about substitution and elimination. All right? So let's talk about dependent systems, and I'll see you next video. Bye.